Alright, so if we get the sum of 84 and 85 all divided by the difference of 231 and we times that result by the last two digits of the year of your birth and increase our result by the quotient of 10 to the power of 3 and the difference of 15 and 5 times by your birthday. And then increase the result by the product of 5 and 2 taken to the power of the sum of 3 and 1 times by your birth month and a numerical value. We get a lot of words. Well, you also get the date of your birth. But that's a problem for another day. Today we are going to look at a very important part of algebra. In fact, our starting point here, which is to look at variables and verbal expressions and to see how exactly do you write different things out. Now, the first thing we're going to start with is subtraction. What are some things that could represent subtraction? One of the big ones that we have is saying something like, we're going to take 15 and 5, and we want to know the difference of 15 and 5. So the result is 10, but why 10? Why do you know it's subtraction? Well, think about it this way. If I gave you a thermometer, well, I don't even have to give you a thermometer. If you look outside and you're like, all right, so it's 20 degrees Fahrenheit, or it's 100 degrees Fahrenheit, what's the difference between those? What's the difference between 100 degrees Fahrenheit and 20 degrees Fahrenheit? Well, in one of them, winter is coming. And in the other, winter is here. Dun, dun, dun. Also, one of them is much colder. But if I have 100 and I have 20, what's the difference? Well, one is 80 degrees hotter. So the difference between 100 and 20 is just 80. All right, so that's one way we can look at difference. We could also say if we subtract 5 from 10. Now what that would be like is that would be like saying I have 10 things originally and I want to subtract 5 away from it. So if I have $10 and I subtract away 5, or I subtract $5 from 10, I only have $5 left. Now that was a terrible example because it was 5 and 10. Let's try and say we have $10 and we want to take 6 away. So I have $6 and I want to take it away from 10. What does that leave me with? 4. So when we subtract 10 and 6, we get 4. Another way we can look at this is we can look at this with unknown values. So this is what we call variables. Now variables can be whatever you want them to be. So if I was to say that I have a certain amount of money and I decrease it by 17, what do I now have? I have $17 less than what I started with. Now if I knew I had $100, then I could just take 17 and subtract it from 100. But because I don't know, I would have to give a value to it. Now because we're working with money, let's call it M. You'll probably most likely see X, maybe Y, those are some of the more common ones, but we're gonna go with M because it doesn't matter. So if we take 17 away from M, it's just M minus 17, and that's what we would write. What about addition? What if we want to take things and add them together? Because especially with money, it might be a little bit better to add it on. So if I have $10 and I want to increase it by 6, what do I have? I have $16. But if I just have whatever's in my bank account, which I haven't checked in a little while, and I have some unknown amount plus 6. And this time, because I said amount, I'm going to use the word A. So if I have A plus 6, that is some amount increased by 6, because we're increasing the value. Another word that we commonly use for this is sum. The value when you total everything together. If we have a sum of money, that's a good thing, right? So if you're like, oh, I have this huge lump sum of money, it's a positive thing because it's a sum. It's a bunch being added together. So if I have the sum of 5 and 4, I have 9. If I have the difference of 5 and 4, I have 1. The product of 3 and 2 is just multiplying 3 times 2, which is 6. And the quotient is if we divide it. So if I was to say the quotient of 14 and 2, the quotient would be 14 divided by 2, which would be 7. And again, if I didn't know the value, if I was using a variable, the quotient of 14 and x is just 14 over x. Now, another way that you could look at this is we could say something like, I want to divide 14 by 2. This is saying the same thing. It's saying take 14, that's the big thing you're looking at, and divide it in half. Divide it by 2. So the other way you could even say this is half of 14. Because what's half of 14? Well, that's just 14 divided by 2. And that's where we start to get a little bit more complicated. We look at fractions, and we look at like having a part of a whole. And that's really all that is. Now, product and quotient, those are opposites of each other. Addition and subtraction, sum and difference, those are opposites of each other as well. Now the last big one that we look at is when you want to take something to a power, to an exponent of something. So if I want to take 3 to the power of 2, that's saying take 3 and the exponent is going to be 2. Or another way that this actually is that exponent is how many times you multiply that number by itself. So 3 to the power of 2, or 3 with an exponent of 2, is 9. 3 times 3. If I take something like x and I want to cube it, that's x to the power of 3. And then we could have x to the power of 4, x to the power of 5. There's a whole bunch of different numbers that you could use with this. The nice thing about this is when the problems start to get a little bit more complicated, like the problem we had at the start, we can apply all of those things that we need. And if we look at this, we can actually create a general case for the problem we had at the start, because I don't know your birthday, I don't know your birth year, I don't know your birth month, but I could still solve it by saying that those are x, y, z. So we'll put it up together. We're going to put all of this in here. We had 84 plus 85. Those were inside our first brackets. And we divided it by the difference of 231. So the difference between 231, that was what was divided. Then we times that full result by the year of your birth. So let's call that x. And then we took that and we added on 10 to the power of 3. And we divided that by the difference of 15 minus 5. So that fell inside our brackets. And then we times that by your birthday. We'll call that y. And then we went and we added on 5 times 2. And we took that to the power of the sum of 3 plus 1. So 3 plus 1 was in our brackets. And then we took that answer and we times that by z. So what actually ended up happening, if you look really closely at this, is the first thing that we multiplied together, that gave us 1 times x. And then we added on 100 times x. And then we added on, again, 10 to the power of 4. Well, what's 10 to the power of 4? 10 with 4 zeros. So 10,000 times the year of our birth. And that actually gave us the numbers we wanted. Because if I put this in, each one of these is going to replace to where it needs to go. And that's where brackets become very important, because you might be trying to put all this in your calculator, and you try and go in your calculator and you're like, ooh, let's do 5 divided by 3 minus 4. And you type 5 divided by 3, and then you put minus 4. And your calculator doesn't really know what you want to do. It thinks you want to go 5 divided by 2, and then minus 3. But if you put brackets around the bottom, then it knows you want to go 5 over that. So it's really important to use your brackets when you can. Brackets are gonna really help you with order of operations, especially if you're trying to simplify things in your calculator. So if you get a really strange answer, there's probably a good chance that the brackets are the reason why. Let's see how we can do. I'm gonna leave you with a bunch of examples. We'll check back in. We'll see that you get the right result. Alright, so how'd it go? Get it done? Alright. Thank you for coming by and checking this out and hanging out with me. It's been a blast, and I look forward to next time. keep mathin' and memeing on.